Welcome, everyone. I'm Kevin Anderson, the coordinator of Austin Waters Center for Environmental Research, and welcome to the 2020 CER Lunchtime Lectures. This year, our theme is Humboldt, Science and the Geography of Nature. Alexander von Humboldt will be the focus of our lectures this year. He lived from 1769 to 1859 and was by far, up until the advent of Charles Darwin, the most significant scientific figure of the 19th century. He lived a long life, but the focus of his life and his work was a 5-year exploration of the Americas. He was appointed in 1789 by the King of Spain to make the first comprehensive scientific exploration of Spanish America. There had been other explorations of Spanish America, but none that was all-encompassing, none that was geographical in scope, and none with the quality of scientific instruments and scientific mind that Humboldt brought to the Americas. We'll talk in detail about this journey through the year, but it set the stage for Humboldt's fame. He traveled into the Amazonian basin, he traveled to Cuba, he traveled down the Andes to Peru, he climbed what was then thought to be the tallest mountain in the world, he traveled by boat to Mexico or New Spain and spent a year there, and journeyed back to Cuba only to be hailed and called to Washington by Thomas Jefferson for a meeting before he returned to Europe. Humboldt was going to the Americas with a great ambition, and he described his ambition as this: I shall collect plants and fossils and make astronomical observations, but that's not the main purpose of my expedition. I shall try to find out how the forces of nature interact upon one another and how the geographic environment influences plant and animal life. In other words, I must find out about the unity of nature. And at the end of his journey, he had a new scientific vision of nature, a unity of isotherms and ecosystems and food webs and watersheds, a vision about climate change, and that nature, this unity of nature, was a complex interconnectivity. When he returned to Europe, he began to produce books, book after book, all funded by his fortune, and he spent all his money publishing these books to the standards that he set, very high standards for maps and other visuals, and then a broad distribution of works. From his great work, The Views of Nature, which may be the first nature writing, to his narrative of that journey, which was by far the most popular of his writings. His essay on the geography of plants, in which he defines biogeography and plant communities. And then his views on the corderas, this view of indigenous culture of the Americas as co-equal to anything that the West had produced in Europe or in the Middle East. All of this work had a huge impact upon Thomas Jefferson and others, but nowhere was the impact more important to science than on young Charles Darwin, who read Humboldt's personal narrative of his voyage and decided he needed to do a voyage himself. He needed to be Humboldt. In the 1840s, Darwin asked his best friend, Joseph Hooker, to tell Humboldt that his whole course of life was due to having read and reread as a youth Humboldt's personal narrative of a journey to the equinoctial regions of the continent. Humboldt would go on his own journey. Darwin would go on his own journey, The Voyage of the Beagle, which he later published as a book that challenged Humboldt's narrative for popularity. But it reflects the vision and the inspiration of Humboldt. As well, on that journey, the most important book that Darwin took with him was his own copy of Humboldt's personal narratives that he read as he journeyed on the Beagle around the world. Late in his life, Humboldt wrote an epitaph, in a sense, for Alexander von Humboldt in a letter to his friend Hooker. He wrote this in 1841, the year before Darwin's own death. I believe that you are fully right in calling Humboldt the greatest scientific traveler who ever lived. You might truly call him the parent of a grand progeny of scientific travelers who, taken together, have done much for science. Humboldt died on May 6, 1859, 6 months before Darwin's Origin of the Species was published, and truly, in the deepest sense, the inspiration for the Origin. It inspired Darwin to become what we now call a scientist, but which then was called a naturalist or a natural philosopher, a scientific traveler. And the term scientist wasn't coined until the 1830s and really didn't come into use until after Darwin had died. So in that sense, neither of these figures were scientists as we know them. What were they? Well, that's one of the things we'll address in the lecture this year, to tease out these different terms of naturalist, natural philosopher, scientific traveler, and ultimately what a scientist is and what contemporary science is. What Humboldt had in mind with this vision of unity of nature was his own approach to science. And at the core of what's been called Humboldtian science is this focus on exploring the world. Nature speaks, and the scientist must go out and listen. And when the scientist goes out to listen, the scientist also collects, gathers data for or against an idea. You take those ideas to the field and test them against nature. And that testing involves measurement, widespread, as accurate as possible with the most accurate and up-to-date instruments. And collaborative, since you're trying to do it on such a large scale, there's no one person that can do that. And with that data, then, you look for patterns. You connect those data points, and those patterns will reveal underlying laws of nature. All of this, then, must be done on a global scale. We want to understand the Earth. We want to understand the cosmos, as he calls it, the Earth and the universe itself. And all of that requires international collaboration. Humboldtian science, then, is the accurate measured study of widespread but interconnected real phenomena in order to find a definite law and a dynamic cause. That definition should be quite familiar to us in this age of earth science. But Humboldt was interested in a science that connected humans to the earth, connected to humans as part of the nature that he was studying. So a tenet of Humboldt's science is that humans are part of nature. Humboldt viewed the world as what the ancient Greeks called a cosmos. He recovered that Greek world and put it into circulation again. The cosmos is the universe as a complex and orderly system or entity, and the opposite of chaos. He coined the modern term cosmos as the title of his final work, a huge 5-volume work that was published between 1845 and 1862. For Humboldt, the term cosmos signifies both the order of the world and, as he phrased it, the adornment of this universal order. Order refers to the observed fact that the physical universe, independently of humans, demonstrates regularities and patterns that we can define as laws. Adornment refers to human imaginative perception of beauty and wonder, and that's also part of the universe, because remember, for Humboldt, humans are part of nature. Imagination, beauty, and wonder are also part of nature then. So looking back at Humboldt has been a practice that has unfolded across the time since he's passed. but in recent decades has picked up steam, especially here in America, where Humboldt had been largely neglected since the 19th century. Part of that was the publication of new biographies of Humboldt, like The Invention of Nature by Andrea Wolff. And that idea, that Humboldt's idea of nature is the invention of the nature that we understand now, is backed up by looking at Humboldt's idea of nature and understanding that in a contemporary context. Because his idea of nature was nature as an ordered unity, as a globally complex system of interconnections, as a cosmos open to imagination and wonder, as a subject for exacting scientific study, and as an object of human mismanagement. All of that is now a familiar concept, but Humboldt invented that. Strangely, after the 19th century in the United States, Humboldt was largely forgotten and only discovered by environmental science in this last 20 years. Well, why? Well, biographies have been written, works have been translated into English that had never been translated into English, but also his idea of science rings true to what we're trying to do with earth science or environmental science. I, as a geographer, would say it was never really forgotten because the discipline of geography is very much Humboldtian science. But that merging of geographers' insights about the earth and nature with broader physical science is what's unfolding now. So what we're going to do over 12 lectures is explore both the background that Humboldt brought to understanding science and the earth and nature, those influences on him in the context of being called a naturalist or a natural philosopher or a geographer. January and the beginning, and today we'll talk about natural philosophy and the study of nature. Then we'll go on to look at the parallel practice of natural history that led to the idea of the taxonomy of nature. Then we'll look at the context of this scientific knowledge, of the ecological imperialism that unfolded as Europeans explored the globe from 1492 to the 1800s when Humboldt went and explored. And then we'll look at this idea of science of nature and Humboldtian science in the context that Humboldt knew, where Kant was promoting this idea of physical geography as the definition of earth science, and Humboldt carried that with him through his writing and through his life. We'll then turn to that life itself, and as Humboldt was educated and then moved out into the world, that's a lot to unpack. He lived a long life and he had many influences and influenced many people. So we'll do 5 lectures trying to unpack that part of Humboldt's influence. And we'll end the lectures looking at 3 different aspects of his influence that's contemporary, that's impacted the 21st century as we rediscover Humboldt. From understanding humans as the great disruptors and human modification of the earth over time, which Humboldt first recognized and identified as significant. Then we'll look at the idea of this new science of the environment, earth science, environmental science, and that somehow humans can manage the earth. And we'll end this series of lectures both where we began, looking at the geography of nature, but also in this contemporary understanding of the Anthropocene, of Gaia, and where Humboldt fits into that story. So it's a big journey. It's a long journey. There's lots to unpack. Let's get started by looking at natural philosophy and the concept of nature. Now, natural philosophy is where Humboldt began, because what he was doing very much was considered in this tradition, this 2,000-year tradition of studying nature. And in the ancient world, starting with Aristotle, this practice of studying nature was called natural philosophy. Later, Francis Bacon, with the scientific revolution, will point to natural philosophy as the great mother of the sciences. From the practice of natural philosophy, then, with Aristotle, in the 19th century will come the emergence of all of the sciences that we know them as them today, but which were all considered under the umbrella of natural philosophy up until Humboldt's time. So this practice of studying nature, physica, the physical universe, was considered to be part of philosophy. And this part of philosophy called natural philosophy was distinguished from the other precursor of modern science, natural history, in that natural philosophy involved reasoning and explanations about nature, whereas natural history was a more qualitative and descriptive study of nature. And that will take another lecture to unpack what natural history was and its history. But today we're focusing on natural philosophy, this attempt to reason and explain nature. The term science, which will emerge again in the 19th century, was still used back then, but science, scientia, meaning knowledge, was a broader term for different types of knowledge. There was the science of ethics, of politics, of art, of crafts. Mathematics, astronomy, and physical nature all fit under sciences too. And in that sense, we can understand why Francis Bacon would point to natural philosophy as the great mother of sciences. Now, part of the idea of these lectures is to introduce you to various books that I want you to go read to fully unpack these stories, because I can't do that in the short time we have in these lectures. So if there's one book that I could encourage you to go to find to understand a history of natural philosophy, well, it is a history of natural philosophy. From the ancient world to the 19th century, Edward Grant's great history of science about natural philosophy, and I'll be using that in this lecture too. What happens with that story is the Greeks decide to reason about nature, to tell these stories that are more than stories, that are grounded in logic. And when we talk about Greek philosophy, well, there are many Greek philosophers, but there are three key figures. Socrates, who wrote nothing that we know of. We know his philosophy from his student Plato, who may have written things, but wrote them in a form called the dialogues, and we have those to work with. But it's from Aristotle, Plato's student and contemporary, the successor of Plato, who was the successor of Socrates in teaching philosophy at Athens. Aristotle was the one who did the most detailed writing and gives us thought structures that we bring today through philosophy. At the core of this, then, is Plato. And Plato is important as a foil against which to understand what Aristotle is going to do with philosophy and natural philosophy. So we have to think a little bit about Plato. We don't have much time here to really dig into the greatest of the Greek philosophers, but the fundamental distinction in Plato's philosophy is critical here, because it's a distinction between the many observable objects that appear beautiful or good or just, unified, equal, or big, and the one object that is what beauty, goodness, justice, unity really is, from which those many beautiful, good, or just, or unified, or equal, or big things receive their names and their corresponding characteristics. So it's the property of beauty, of goodness, of justice, which is the one. And then what those things, that property is applied to, which is the many. Plato believed then that the true substances are not physical bodies, which are beautiful, because these are ephemeral. So it's the eternal forms, of which physical properties are imperfect copies, that are the true substances, that are eternal. These forms not only make the world possible, they also make it intelligible because they perform the role of universals. They allow us to understand the imperfect copies here in the physical world. Similarly, the human body is imperfect and ephemeral, but the human soul or the human psyche or mind is eternal and capable of knowing the truth of these forms. And that is the work of the philosopher. Plato brought forward this allegory of the cave to describe the situation we are in trying to understand the physical universe. The invisible world is the most intelligible and trustworthy, but the visible world, known through the senses, is the least trustworthy and the most unreliable. In the allegory of the cave, it's the forms or the eternal, which is shedding light on the shadowy world of the cave that we live in. And it's those shadows that we take as real, but those shadows are unreliable. They're not trustworthy. And it's for the philosopher to try to turn to the light and explain to other humans what those shadows are and what they mean. So Plato's theory of the forms, where the one and the good and the beautiful are eternal and somehow beyond the physical world, give an epistemology, a way of explaining how we know the world and how we understand the world, and give a very coherent structure to that understanding. And this is what Aristotle learned from Plato, who learned it from Socrates, his teacher. But with many teachers and students, there comes differences. And it's the difference between Aristotle and Plato that carries through Western culture and brings us into this emergence of science as we know it in modern times and in Humboldt's time. Because for Aristotle, it wasn't the heavens that define knowing. It wasn't the forms that underline all knowledge. It was Aristotle's belief in knowledge through empirical observation and experience that was more significant and the thing that he argued for. And so there was a break between Plato and Aristotle that comes down to us in great artworks like this, where Plato is pointing to the sky and Aristotle gesturing back to the earth. The difference between the teacher and the student becomes real in the philosophy of Aristotle. And at the core of Aristotle's difference from Plato or Socrates is the formalizing of the tool of reason that will allow us to understand the empirical world and to have confidence in our judgments about it. Literally, the Greek word for tool is the term that we use for a collection of books about logic that we get from Aristotle. Aristotle found the universal in particular things, which he called the essence of things. And Plato finds that the universal exists apart from particular things and is related to them as their independent prototype, an eternal exemplar, which he called the form. For Aristotle, it's this essence of things that he's trying to identify and then explain how we interact with that. And this is why logic is central to the Aristotelian project of knowledge and nature. For Plato, logic means the descent from a knowledge of universal forms or ideas to the contemplation of particular imitations of these, a deductive process producing a logic of relation to these ideals in the heavens or in our intellect somewhere. For Aristotle, logic implies the ascent from particular phenomena to knowledge of essences, an inductive process from these particulars, from observation, producing a logic that tells us what belongs to what, knowledge of kinds of things. What are spiders? Spiders are those creatures that have 8 legs. So this inductive process, which takes the form of syllogisms that uh, Aristotle defines as part of formal logic, leads us to this definition of, in this case, spiders. And then we can use that definition for further deduction and scientific demonstration, this demonstrative knowledge that we can have confidence in. Now, knowledge is at the key of this sorting out that Aristotle is going to do. And he sorts out knowledge into 3 basic types. The theoretical sciences, which we will focus on next, where you can have universal knowledge of the earth. But Aristotle, as a very practical philosopher, includes the productive sciences, the crafts of making useful objects. He calls this techne, the technical know-how to do things and make things. And then the practical sciences, which focuses on human conduct, ethics and politics. Phronesis, he calls this, practical wisdom. And so not only is there scientific knowledge as important, co-equal to that are the skills and crafts knowledge and practical wisdom too. This helps define Aristotle's broad philosophical system. But it's the theoretical sciences out of which comes natural philosophy, or physics, as we might call it. But also in theoretical sciences for Aristotle is metaphysics, the book beyond physics, things that are unchangeable and distinct from body and matter, eternal substance like God. And so the philosopher's job is also to do metaphysics, not just physics or natural philosophy. And somehow in the midst of that, there is mathematics. And again, he's getting this from Plato and Socrates. Mathematical things are also unchangeable things, but they're somehow abstractions from physical entities, 1, 2, 3. And they don't really exist for Aristotle as separate from those physical entities. And that's a difference he has with Plato. But this relationship of mathematics, or what he calls the exact sciences, things that are unchangeable but are abstractions from physical entities. The exact sciences includes the very mathematical study of astronomy and optics and mechanics. These mathematical sciences don't fit easily into the theoretical sciences. And so there's a question mark there that plagues natural philosophy from its beginnings with Aristotle. How do these exact sciences fit into his schema? In astronomy, where does the balance lie between the mathematical and the physical? Must the astronomer concern himself with the real structure of things, as Aristotle's astronomical scheme suggests? Or is it an ideal? And here then is at the beginnings of Western science is a fundamental question, and one that David Lindbergh addresses in his great book, The Beginnings of Western Science. In addition then, with this question of theoretical science is the question of medicine, which is in some ways a personal question for Aristotle since his father was a physician. How does medicine fit in? Is it merely a productive science, a skill or a craft, or is it a theoretical science? Again, here we have this in between. Where do the exact sciences fit? Where does medicine fit in this schema that Aristotle creates? And it's a fundamental question because what Aristotle is trying to do is give a description of the cosmos, of the universe. In his books on the heavens and the physics, he's trying to put forward this notion that the universe does have order, that is rational, and that is understandable by human intellect, this rational intellect. But it's also a physical thing, not just an abstract thing. And this cosmology that Aristotle produces, this cosmos, has 2 distinct parts. The sublunary region from the moon and down to the earth and us, and then the celestial region beyond the moon. The sublunary then is the abode of change and corruption, where things live and die, come and go. The celestial beyond the moon is a region of perfection. There's no change there. It is eternal, and it's governed by a concept of place as opposed to space. Nothing is empty. All is filled in Aristotle's cosmos. And everything then in this filled thing called the cosmos has its natural place, a privileged location for bodies with a particular makeup. And it's their makeup that determines where they fit in this cosmological structure. So everything is a continuum. There are no empty places. There's no vacuums. There's no space. And all of it is finite. At the edge of the cosmos, well, that's it. There's nothing, not even space. There's no beyond. The cosmos encompasses all existence and had no temporal or beginning or end. Remember, that celestial region is eternal. Now, this story is what we carry on into Western culture. And of course, some of these features are going to cause problems as it tries to fit into Western religion, into the Judeo-Christian tradition, and even into science. So astronomy and theology are all part of Aristotle's cosmos, but his explanation, his theological explanation, is also a physical explanation of where things are. The heavenly bodies, those things beyond the moon, are part of spherical shells, perfect circular motion, and those physical objects that are there, the planets, the sun, are embedded in the fifth element, or quintessence. This fifth element fills everything in that celestial region. These spherical shells fit tightly around each other. There are no spaces between them, and the earth is in the center of this story. For Aristotle, it's a geocentric universe. The natural motions of the heavenly bodies and their spheres are perfectly circular and neither speed up nor slow down because, of course, there's perfect motion in that celestial realm. Outside of the sphere of the fixed stars, there is another sphere, and this is the sphere of the prime mover, who imparted motion from the outside inward. We might call this God. We might call it a more abstract thing that started all of this. But it's a necessary component of the full explanation of the cosmos. The mover, of course, himself is unmoved, because if the mover was moved, there'd have to be another prime mover. So to avoid an eternal regress, the prime mover is the unmoved mover. All motions in the cosmos came ultimately from this prime mover who is eternally unchanging, and after that first push, does nothing, does not intervene in the world. And of course, here you can imagine the tension that comes with a Christian God who is allowed to perform miracles and is deeply involved in the world, and Aristotle's God that has little to do with it after that first moment. And so what Aristotle is doing then is a natural philosophy. This is not a theology. This is an attempt to explain nature. And the celestial region then is a region of perfection. The sublunary region is the region of change, of separate existences, individual particulars, things that are changeable. And so what he has to explain in the sublunary region through his natural philosophy is where things come into being, grow, mature, decay, and die. And so how do you explain order in the world and change? And so here what he does is not one element like quintessence, because he's explaining imperfection, not perfection. Here he's explaining change through four elements. The heavy elements, earth and water, and the light elements, air and fire. And all physical things, Aristotle says, are made up of two or more elements. Earth and water are heavy and tend to move downward. Air and fire are light and tend to move upward. And so with these four, he can explain motion, change, transformation. So in this sense, what we would understand him to be doing is physics as we understand it. But he's trying to do much more. He's trying to explain everything in nature. In explaining motion and change, the elements are the material cause of that. But there are also other causes that Aristotle identifies in his cosmology. The other is formal cause. An object's motion will behave in different ways depending on its material arrangement, its shape, its form, literally. The square shape of a table, for instance. And when we have the square shape of the table, we have to explain the efficient cause that brought that particular table into being. The efficient cause then is that which caused the object to come into being. In the case of a table, the agent of change or the agent of movement is a carpenter building it. And then because everything in Aristotle's cosmos has a reason for being there. That reason that caused the object to be brought into existence is called the final cause. And the way we understand that is the purpose of the thing. The purpose of a table, of course, is to hold objects. The purpose of the human is to understand the universe. And so Aristotle's natural philosophy is also understood as something we call a teleology, a universe in which everything has a purpose, and that's its final cause. So these four causes allow Aristotle to do a whole lot of philosophical work, and a whole lot of work that we don't recognize as part of science anymore. And that's part of the story we'll tell today, how some of these causes were stripped away from the scientific project. Now, nature as we know it is not just physical objects, but living things. And Aristotle, unique among this triumvirate of Socrates and Plato and himself, Aristotle was deeply interested in living things. Not only in the things themselves in a descriptive sense, in the sense that we call natural history that I'll talk about in the next lecture, but also in explaining the relationship between them, in classifying them in relationship with each other. And in his books on animals, the generation of animals, the history of animals, the parts of animals, Aristotle made this first attempt in the West at taxonomy, at understanding the order of living nature. In the broadest sense, he recognized the differences between vertebrates and invertebrates. He called them animals with blood and animals without blood. He looked at the broadest relationship between all living things and saw that there was, in his view, a natural scale, a relationship of complexity, of structure and function that came to be called the great chain of being. Higher organisms showed greater vitality and the ability to move. He ranked animals over plants based on their ability to move and sense. He graded the animals by their reproductive mode, animals that gave live birth being higher than laying cold eggs, the possession of blood, warm-blooded mammals and birds being higher than bloodless invertebrates. This great chain of being is a graded scale of perfection rising from plants up to humans at the top. Humans then have the ability to grow and reproduce, just as animals have that in plants. But humans also have the ability to move, which plants do not. And then over animals, humans have the ability to think rationally, to recognize that there is a great chain of being. Now, that's what Aristotle gives us. And he gives us structures that remain with us to this day. And as the Greek civilization faded and the Roman civilization emerged, the Romans adopted many of these ideas of Aristotle. In an unquestioned sense, Aristotle was the authority. And so you could apply Aristotle's natural philosophy to understanding nature. What the Romans did give us was a much more detailed account of natural history, most famously in Pliny the Elder's Natural History. And we'll look at that next month. As well, we'll look at this tradition of natural history that emerges out of Aristotle and then continues through the Roman and medieval period, where natural history is much more significant than natural philosophy, this attempt to explain nature, because both for Roman and medieval times, you had the authority of Aristotle to turn to. He'd already explained it. There wasn't a need for new explanation. But natural philosophy, in another sense, continues in Roman time in certain areas. One of those areas is that incomplete project that Aristotle left. What is the role of astronomy in this overall story? And when we begin to do practical astronomy, when we look at Aristotle's celestial realm, that is the realm of perfection, of circular orbits, and we begin to collect data on that, well, we realize that heavenly bodies may not move in these perfectly circular motions, because when we look and measure, we see that they speed up, they slow down. Some of the planets seem to even stop and reverse their motion. And it was Ptolemy in Roman times who did the great work of trying to reconcile all of these things that didn't fit the perfection of Aristotle's account into a mathematical construction that accounted successfully for observed motion of each heavenly body. But it was a very complicated Ptolemaic system that added many more types of cycles to the rather simple account that Aristotle gave. And Aristotle's cosmos and the astronomy of Roman and medieval times branched out from an explanation of motion to the practical application of astronomy on human life. And we are bequeathed this practice called astrology, the relationship between the sublunary realm and then the influence that the celestial realm has on us. And astrology as a practice has tensions with Western theology, in particular with Christian, Judeo-Christian theology, and still continues to this day to run parallel to that account. But at its core is the attempt to reconcile the astronomical observations of the celestial realm with the practical, with the sublunary realm. What is our relationship to the stars? And this is something, too, that persists through medieval times and will have to be reconciled in the scientific revolution and modern science. So medieval natural philosophy and Aristotelian natural philosophy have parallels and differences. The difference with medieval natural philosophy is that there was little experimental science as we know it, or as Aristotle knew it, taking its question to nature and testing it, because Aristotle had done that. And so all we need to do is read Aristotle's books. All knowledge contained in Aristotle's books is studied by scholars, and hence the term scholasticism. Now, there was experimentation, and that experimentation focused on Aristotle's understanding of physics, of these four elements: earth, air, fire, and water. And the right combination of these elements produces any substance on earth. This is what Aristotle taught. And so this science, this practice of alchemy, played with these four elements. And at the core of it was the idea that you could transmutate one substance, earth, air, fire, and water, into another. You could take some of these substances and turn them into more precious metals like gold. It's finding the right combination that was at the core of alchemy, to both find ways of producing precious substances and then ultimately the elixir of life. Again, in relation to Christian theology, these were questionable practices that bordered on blasphemy, since this was the power that the Christian God was supposed to have. And so they get labeled the dark arts as well. So scholasticism, theology, through the medieval period, parallels this natural philosophy we inherit from Aristotle and does little improvement on it. It's more endless commentary on what Aristotle taught us about nature. But these problems with Aristotle himself, the relationship between Aristotle's prime mover versus the Christian God, a prime mover who gave no intervention into the sublunary realm, was not omnipotent, stands in contrast to the Christian God. And then there was the problematic tendency in natural philosophy that we see both in astrology and in alchemy, the tendency to restrict analysis to causal principles discoverable through the exercise of human observation and reason, without regard for the teachings of biblical revelation or church tradition. Aristotle himself was not a Christian. And so that tension between the divine and the natural is there too in medieval philosophy, especially in late medieval natural philosophy as it was practiced. Divine or supernatural causation was never denied, but it was placed outside the province of natural philosophy as we move in to the late medieval period. All of this, again, recounted both by Edward Grant and David Lindbergh in, I think, two key books that I would recommend. So now we move to the stage where all of those problems have accumulated, in particular the astronomical problem of that celestial realm, the problem of astronomy itself as studied. Now those problems that were built into the Ptolemaic system need to be fixed. And this truly was the start of what gets labeled the scientific revolution. Nicholas Copernicus finds a solution to the Ptolemaic problem. And his solution is to dethrone the Earth at the center of that universe and move the sun there. But he leaves those perfect orbits. He leaves those circular and spherical structures that make up the celestial realm that Aristotle gave us. So it's a partial solution to reconciling the observations that have been made, but a key one in that, unlike the Christian cosmology, which has the earth at the center of the earth at the center of the universe, he now moves the sun there. But Copernicus's problems, the perfection that he assumed for those celestial orbits, also had to be fixed. And so the key moment in the scientific revolution after Copernicus dethroning the Earth at the center of the universe was Kepler recognizing that the celestial realm was not perfect and showing that mathematically, that those orbits were not circles, that elliptical orbits with the sun at one focus of that ellipse explained everything. And it's in that context that natural philosophy is recognized as the mother of all sciences, because it's at this point that Francis Bacon declares a new tool, a novum or an organum that is going to address this question of nature. Where Aristotle applied logic itself, Bacon is going to argue for what we now call the scientific method. This wasn't Bacon's term. It's a term that was summed up in the 19th century, but the practice itself is at the heart of Bacon's new way of analyzing nature. Bacon argued that scholastic natural philosophy was too focused on what Aristotle said in his books rather than physical nature itself. The natural philosopher should instead take the question to nature and learn by direct observation and experiments, just as Aristotle had done. Rather than simply look at Aristotle's books, the natural philosopher now needs to go out into the field. Bacon's emphasis on the use of artificial experiments to provide additional observations of a phenomenon is one reason that he's often considered the father of experimental philosophy. We need to test nature itself with these experiments rather than just observe. We're not doing just natural history, we're doing natural philosophy. And natural philosophy, as defined by Bacon, is an experimental natural philosophy. Apart from the laws of nature themselves, the causes relevant to natural philosophy, as Bacon defines it then, are only the efficient and material causes, matter and motion, the thing that things are made of, and the motion that they exhibit in the universe. He's doing away with Aristotle's formal or final causes. No longer is the universe a teleology filled with purpose. It's a universe of efficiency and matter. Now, what this does in terms of philosophy and natural philosophy is open the world to new knowledge. And the context in which this is happening, of course, is post-1492, when a new world has been discovered, where explorers have sailed off to the West and discovered a world that was unknown to Aristotle. So literally, you can't go to Aristotle to learn anything about that. You have to go to those sailors and explorers themselves. And a natural philosopher for Bacon can be the same thing in the old world, not just the new world. Bacon hopes that empirical investigation will smash the old ideas of natural philosophy and lead to a greater understanding of the world and the heavens, just as Kepler smashed the heavens. Discovery of new knowledge is possible. That realization, David Wooten writes about as the core realization that allows science and the scientific revolution. The dramatic success of the new science in explaining the natural world promotes this natural philosophy as an independent authority, challenging the old authority and the old theological philosophy. It allows the construction of a new worldview. The frontispiece of Bacon's book is the sailing of galleons going through the mythical pillars of Hercules to the other side of the Strait of Gibraltar, from the Mediterranean to the Atlantic, out into a new world. This is what the new science can do. Experience as a great teacher changes from learn from the past to experience can actually teach you that what other people know is wrong. It is experience in this sense, experience as a path to discovery, Wooten writes, that was scarcely recognized before the discovery of America. Now, other historians of science and certainly philosophers would argue that scarcely recognized may be too strong a term because, of course, Aristotle was discovering new knowledge too, right? With techniques that are quite similar to what Bacon's arguing, but with a different cosmological context. And so historians of science, these historians have a very fundamental debate where medieval and early modern natural philosophy, was it continuous with each other, or was it discontinuous? Was the scientific revolution an abrupt break from this late medieval practice? I and others would argue that it was much more continuous. Wooten and other historians argue that it's discontinuous. Both have valid points to make, and both are part of the broader insight of this change over time that finally will bring us to something we call science out of natural philosophy. And Bacon surely is a key figure in that transformation. 1620 and the publication of his book sets the stage for a rethinking of the relationship, not just of natural philosophy in the world, but natural philosophy and mathematics and the exact sciences. And this is a point that Edward Grant makes a focus of his work. Francis Bacon gave voice to the most significant problem that confronted natural philosophy in its lengthy history from Aristotle onward. What is the proper relationship between natural philosophy and mathematics in the exact sciences, like astronomy and optics? Bacon was convinced that the great mother of sciences, natural philosophy, had to embody within itself all the exact sciences because it nourished within itself a multiplicity of specialized sciences, such as physics, chemistry, biology, and all of their subdivisions. And mathematics was the key to unlocking the power of those sciences. Natural philosophy then had to merge with mathematics and the exact sciences. This was Bacon's argument, and it was resolved by the genius of two men. One, Galileo. And Galileo, looking at this relationship between the Ptolemaic cosmology and Copernican cosmology, which of course got him in trouble with the Catholic Church. But his argument was that you had to dethrone the Aristotelian physical categories of the celestial element and four terrestrial elements and their different directional natures of motion, and in their place leave only one element: material nature, corporeal matter, stuff itself, and then have a different way of describing properties and motions of matter in terms of mathematics. That argument of Galileo is resolved and changes all of the world. And it was John Donne in his poem, The Anatomy of the World, that sums up this change that Galileo and Copernicus and Kepler and Bacon are all creating. He calls it the new philosophy. And he writes, "A new philosophy calls all in doubt. The element of fire is quite put out. The sun is lost, and the earth, and no man's wit can well direct him where to look for it. And freely men confess that this world's spent. When in the planets and the firmament they seek so many new, they see that this is crumbled out again to his atoms. 'Tis all in pieces, all coherence gone, all just supply and all relation." This was the anxiety of the scientific revolution period, and the anxiety of a world that cries out for mathematical explanation. And it's resolved in the work of Newton. This reconciliation of mathematics and natural philosophy, this renewed coherence and relation, is what's detailed in what's called Principia Mathematica, but whose title translates into Mathematical Principles of Natural Philosophy. Published in 1687, here we have the reconciliation of Aristotelian exact sciences and mathematics with the practice of natural philosophy. As Grant points out, by the end of the 17th century, the transformation of natural philosophy was manifest in Newton's great work, the very title of which reveals that a union of mathematics and natural philosophy had already occurred. The scientific revolution occurred because after coexisting independently for many centuries, the exact sciences of optics, mechanics, and especially astronomy merged with natural philosophy in the 17th century. This momentous occurrence broadened the previous all too narrow scope of the ancient and medieval exact sciences, which now, by virtue of natural philosophy, would seek physical causes for all sorts of natural phenomena rather than be confined to mere calculation and quantification. So in the 1600s, this scientific revolution was a revolution in many senses. But at the core of it was this reconciliation of mathematics and natural philosophy through Newton's great work. So when we turn to Humboldt, as we will in the coming lectures, he was aware of that historical context. He, as a young man, of course, had to study Aristotle. He had to look at these contemporary figures to him, recent figures who mathematicized nature. And so exact measurement and a vision of the unity of nature, a cosmos both ordered and beautiful, these Humboldtian ideas are historically well grounded in Greek ideas from Aristotle and Plato to more contemporary ideas for Humboldt of the scientific revolution of the century before his birth. Unity and diversity, and of connection, resemblance, and order among created things most dissimilar in their form, one fair harmonious whole. That's what Humboldt will say the cosmos is. But Humboldt isn't alone in saying that. Humboldt stands on the shoulders of all those thinkers that came before him. But Humboldt is the great synthesizer of those ideas in arguing for a new Humboldtian science. So that's where we are at the beginning of this story. And that story of natural philosophy is a context that Humboldt begins his life with in the 1700s. But it also is the context of natural history. So in our next lecture, we're going to go back to Aristotle again and follow a second pathway forward that merges with scientific practice and the scientific revolution. And it's the pathway of natural history. And it's a pathway that begins with Aristotle and his attempt to explain the order of living nature, a taxonomy of nature that in Humboldt's lifetime becomes biology. Later, we will move on to looking at some of the other background to Humboldt's understanding before we then launch in June's lecture into Humboldt's life itself. But join me for the next lecture and we'll look at the origins of natural history and Western culture and the taxonomy of nature. Thanks for joining me today. See you next time.